Hey, it's Matthias Noy out of the Gronau office, and today I'd like to talk a little bit about the new tachometer charm that we're supporting since the asset monitor comes from firmware version 2.0, which is released in June timeframe 2021. So as you see, I already opened my box, I connected from the browser to the asset monitor, and you see the charm section where I have at slot one tachometer charm. And if clicking to the charm, I see that this is not configured. It's unconfigured by now as it comes from delivery state. So just pressing the configure button over here and see the parameters. So at the basic section in the parameters, I can just enter a name and I call it tachometer or tach only. You can have optional parameters for description or cabling ID, point ID, KKS numbers, whatever is required here. But the main effective thing here is about the detailed section that can be found from here, where you first can choose one of the three different sensor types from functionality perspectives that we're supporting, which is per default the Hall effect sensor, but you can also choose a passive magnetic probe, an MPU, or you can use eddy current measurement chains for measuring the speed as well, looking to the pulses coming from a trigger wheel or just a pulse wheel. So first of all, looking to the Hall effect configuration, so what you can choose here is a wheel type. As said, it could be a one-tooth wheel or a multi-tooth, which is a key wheel or a trigger wheel tooth wheel. So for me, it is a one-tooth wheel with a symmetry of around about 5%. So the notch at my wheel is just 5% of the overall scale of the circle of the rotation. So I'm entering the symmetry over here. If you're looking to a pulse wheel, for example, multi-tooth wheel, the number of tooths must be entered as well, and the symmetry should be typically 50%. So the width of the tooth and the width of the notch is identical in length. If it's not, you can enter the symmetry over here, and you always need to enter the symmetry of the shorter part independently if it is the notch or the tooth itself. So going back to the one-tooth wheel for me, so you can enter the maximum speed. So for me, from my demo over here, let's enter 4,000 RPM, which is the maximum I'm able to do. About the trigger threshold limit, so that's depending on the voltage amplitude that's coming from the sensor into the charm. And you need to make sure that the trigger thresholds are within the amplitude range that's resulting from from the signal provided to the input of the charm itself. If you already have a guess over here, you can enter this. Otherwise, I recommend to set up the charm, measure the voltage by looking to the waveform that's shown from screen, and there you can directly see about the amplitude parameters, upper and lower maximum of the amplitude coming in, and from that you can easily decide where to set up the trigger thresholds. Make sure they are within the amplitude range, as those upper and lower trigger thresholds make the pulse count working properly as it's looking to the coming tooth or looking to the going tooth, or coming pulse, going pulse finally within the signal, and this is a requirement for measuring the pulses. Then we have a zero speed detection time that can be configured. And that means finally, it's the time, the duration, the charm is looking for pulses coming in until it's responding with 0 RPM. So that means if 10 seconds are no pulses coming in, it will show up 0 RPM after that. If you like to see the 0 RPM a little bit faster, you can reduce this time to at least 1 second finally. And last but not least, we're having a display range over here, which means that the display range is only the scaling inside of the dashboard on the screen, if you're looking to the Asset Studio web interface to see the live data that is measured by the asset monitor. So from display range perspective, with a maximum speed of 4,000, I like to see the full range over here. And this is a requirement that you need to set up for Hall effect. But if you're now looking alternatively to a passive magnetic pickup, you see that you also choose about the trigger wheel. So it could be one-tooth or multi-tooth. It's same configuration here. If you're having number of tooths, the symmetry should be entered. Then you have a measurement mode, and this measurement mode is some variation where you can stabilize the measurement finally and having the values, the measurement value, not fluctuating so much on screen if you don't want to see that. So you can decide between standard, which is a good value for all the measurements. But if you have low speeds, specifically, we recommend to go to the standard plus stabilization. Or if you definitely want to have the trigger wheel considered completely, if you're looking to multi-tooth wheels with a large amount of tooths, then we recommend to go to one full rotation, which having not too much variation and fluctuation in the value, responding by the tachometer charm finally for the speed measurement. And after that, you see again the trigger threshold limits need to be entered. Depending on the MPU, this can vary a large. So if you have low speeds, the amplitude might be a low amplitude value only. If you have fast speeds, the response value, the voltage coming into the tachometer charm provided by the sensor may be higher voltages. So this is a little bit, try and error finally after looking to the amplitude, to the waveform that's responded into the asset monitor, depending on how the sensor is installed as well as what type of sensor has been used. So that's no fixed value. We can easily go up to 20 volts or up to 30 volts, as you see that over here as well. And let's say, for example, the trigger threshold lower part should be 5 volts, upper 20 volts. If you have a 30 volt amplitude coming in. And zero speed detection time, as described before, is a parameter here as well. Display range is what should be shown on the dashboard, as said before. And last but not least, the third opportunity for choosing a sensor would be the proximity probe. And this means an eddy current sensor. And the unique thing about the eddy current sensor is that the input voltage coming back from the sensor into the tachometer charm is a negative voltage here. And for that perspective, you see the voltage limits of the measurement range of the proximeter itself. So for me, let's say it's around about 24 volts negative, and the lower part should be at -2 volts. I'm looking to a one-tooth wheel. You see for the multi-tooth wheel, same parameters about the measurement mode, symmetry, and number of tooth. But for me, it's just a one-tooth wheel. Maximum speed is configured. Trigger threshold should be set up as well. So you can easily set that up after you know about the amplitude coming in. And last but not least is zero speed detection time from configuration parameters, and for sure the display range as well. Now after having this set up, you just need to save your configuration, and this means the charm now starts synchronization, and I'm starting my demo as well. So you see now that there is some amplitude coming in, and with this scaling in time, you see that this amplitude is around -10 volts. So I'm now going back to the configuration and see that it is around -10 volts. So let's set that to -12, for example. No, that's -12 and -8. And you see now we're saving that. You see that the speed is measured, the pulses are detected, as now the upper and the lower trigger threshold is within the voltage range of the signal that's coming in. And that's it finally for bringing a tachometer charm into functionality. And as said, you have 3 different types of sensors available for choice, and the variation in configuration is quite easy and does not differ too much, as it is a speed measurement, just looking to pulses and counting them, measuring it over time. And that's it.